That'd be a suggestion I would have for her, yes.
Would apple work?
An apple would work, yes.
I'm
I'm just telling you, you like it when I'm happy, and I like chocolate. It is what it is.
I really don't like cherry.
Okay, let's see stuff to do today. I'm looking for help, so let's back up with Math Workshop while I copy that for Xavier because he forgot to remind me. So Math Workshop, general reminder because someone last week lost their mind. They tried to turn in. I don't need your old Math Workshops. I got my own old Math Workshops. I don't need yours. However, we are going up with our Math Workshops because eventually we're going to have a test. At the end of this 9 weeks, we will have a test. So on the test, it will not be easy. It will not say what was number 1 on page 28. Instead, it'll be a problem similar to number 1. Here are all of them. It'll be a problem similar to this, and you just have to show me you can do the math. So if you're not actually doing the Math Workshops, like on your own, it's giving me some problems. And that is another 60% grade, by the way. Okay, everyone should start off at least on 1 point. If I haven't given your group more than that already. And for the love, make sure everyone's name is on the strip. At least for today, or else Miss Compton will be confused the rest of the week. Okay, with a volunteer for number 1, yes, Travis. Tell me, dear. Okay, and that's not going to be quite it. We need to try to help you out, Table 4. Go ahead. I'm actually wanting you to FOIL. Yes, every grade. X squared minus 6 is all she got. So, Brady, you're going to say today?
X squared minus x minus 6.
Okay, so first of all, I didn't give you any directions. That's the first problem. And you can have a point for that. First issue is I didn't give you any directions. However, you're supposed to know what to do. You are. So 2 weeks ago, we had some Math Workshop questions that looked similar to this, but there was a plus sign in between. If there's an operation in between, we cannot FOIL. But there's nothing in between those two parentheses, so we're supposed to FOIL. Looking over your tests, we're very good at hard stuff. You can do problems that I don't think you should be able to do. You can do some absolute value ones. But easy stuff like combining like terms and saying x plus x is 2x, negative 3 plus 2 is negative 1. Yes, I get that wasn't our problem today. I'm just referencing it. Easy stuff like combining like terms is an issue for about 3 in the room. Don't know why. They're trying to make life too complicated, and they need to ask me some more questions if they're confused. When we FOIL, the F was for first, so x times x is x squared. The O was for outer, so 2 times x we get 2x. The I was for inner, negative 3 times x is negative 3x. And the L was for last, negative 3 times 2 is negative 6. When we combine those like terms, we do end up with what we have in purple, the x squared minus x minus 6. Now I'm explaining it this time, but my hope is that we're so smart in our brain, we no longer have to draw in those arrows for first, outer, inner, last. And we no longer even have to write down what we have in green. Hopefully we're so good in our head, we combine those outer and inners in our head and just give Miss Compton the final answer. That's what I'm hoping for. If you need to write it out on your paper, that's fine. But what I'm hoping for is the final answer. Okay, so saying all that, can someone tell me the answer to number 2? Yes, dear.
3u squared plus 13u plus 14.
And that's how your group gets a point too. Okay, is there anyone, and it's okay if you're honest this time, I'm not mad today. Not mad yet. Is there anyone who needs me to explain where he got 13u? Okay, that's fine. Okay, so the first was 3u squared. You're good with that. The outer was 6u. The inner was 7u. And then the last was 14. So in his head, he combined the outer and inner and got 13. And you can totally do that. I know you can. Okay, I'm hoping a different group volunteers because this group's still in all the points. Yes, dear, number 3.
8q squared minus 2a plus 1.
8q squared minus, what?
2q plus 1. 9.
Fix it, Abby Grace.
8q squared minus 6q plus 1.
Okay, Abby Grace. You have your point. Okay, he was completely right with the 8q squared, and his last was right with the positive 1. However, did he, in his head, for the outer and the inner, did he have negative 2q minus 4q and get negative 6q? Yes. You can have a half a point. If you can keep up with it, you can have a half a point. So again, the outer and the inner was negative 2q, negative 4q, and that makes the negative 6q. All I had planned for today is 1 through 3. But Caitlin's smart enough to realize 4 and 5 are also FOIL problems. She really wants her group to get points. She's got to make sure she has those done and they're perfect by tomorrow so she can just volunteer straight away. In fact, you know you're more than welcome to work as many math workshop problems in advance as you would like. That is not a problem with me. Moving along. The very first page of the new packet is our new learning targets for the unit. The reason there is a gap is because we're actually going to have 2 different tests this chapter. We're going to have a test on the first chunk of chapter 2 and then a test on the second chunk of chapter 2. So that's where there's a gap in the learning targets for those of us who just like to be in the know. Again, I write learning targets on the board because I'm supposed to. You don't have to write them down. My thought with the list is that when Xavier thinks he has it, maybe he'll put what date he mastered it, like he got it down today, which is 8/28. Hopefully Xavier can then pinpoint when he comes to see me like, Miss Compton, I did not understand that second learning target. I don't understand how to do this specific skill. John, I don't understand anything, but a specific thing he doesn't understand, so we can go over that specific thing. That's if he's trying to make his life useful, that's what this list is for.
Useful or easier?
Huh? Easier. Okay. Okay, moving on to the back. Not going to lie to you. My brain's kind of on the weekend too. So for that first one, I don't remember what I'm supposed to put in that first blank. So we're talking about relations and functions. We're done simplifying equations. My gosh, you know how to do that. I know what a set of ordered pairs is. I don't know if they're looking for the word point. A set of ordered pairs. So a relation, maybe? Relation. Or maybe they're looking for coordinates. I don't know. I can come up with a lot of different words to put in that blank. I'm betting it's supposed to be relations since the top of our note says relations and functions. But I'm being so blind today, I'm just going to put x comma y. Make no promises. I swear I know how to do everything else. It's the easy stuff, like counting, that I can't do. Okay, so when we talk about x values, those numbers are called the domain. When we talk about y values, those numbers are called the range. And then in Algebra 1, you spend a lot of time on this word, which is function. It's a relation where each element of the domain is paired with exactly one element of the range. So something in the domain is going to exactly one element of the range. So if it's going to 2, we have a problem. Yes, dear?
Let's just say depending on what is a relation.
I had a feeling it was. Yeah, I had a feeling it was. Mostly because context clues. The note said relations and functions. But, you know, I hated to lie and say for sure it was. Okay, so an example of something that's not a function. The one that comes to my mind in real life is us in the vending machine. So we go to the vending machine and we put in our 75 cents. Just because you put in 75 cents doesn't for sure mean you're going to press the button for chips. Heck, there might be some candy also listed for 75 cents. So when I put in the money, there's no way Xavier can guess what I'm going to buy. Unless for some reason each item is a different price, which is not the case with a vending machine. Okay, if I go to Starbucks and I order a Grande Caramel Light Frappuccino, because that's my drink, if they don't hand me back a Grande Caramel Light Frappuccino, I'm going to be mad. I'll probably drink whatever they hand me because I'm that person. But in my head, I'm going to be mad.
And like the grande, like the smallest one.
No, that's tall.
Isn't that a single?
Darn Starbucks with their sizes can't do small, medium, large. Anyway, the whole point with Starbucks, whatever I specifically order, if they don't give me that specific drink back, that one input gives me that specific one output. Okay, that's my real world example today. So let's skip that chart for a second and go to the 3 examples at the bottom. Dear? No. No, in fact, they normally do everything I want and more. Okay, so I need to know on example 1, it's a list of ordered pairs. Is this an example of a function or is it not? Is every domain going to only one in the range? Yes, so this is a function. Okay, now for a point, can someone tell me yes or no on number 2 and then like words as to why?
No.
Yes, dear?
No, because 2 is repeated in the X domain.
Okay, it's not a function.
Yeah.
And that is correct because of 2 is getting mapped to 2 different things. When we put in the 2, we're not sure, are we going to get out negative 2? Or when I put in the 2, am I going to get out positive 2? Since we're not sure, it's not a function. And he can have a point for that. However, there is still a point available. Yes, dear. Because of the negative ones, you can have a point for that. So, yes, he was completely right. It wasn't a function just with the 2's. But, hey, this one's super not a function because it also has an issue with negative 1. We're not sure if negative 1's going to negative 1. We're not sure if negative 1's going to 1. So there are 2 different reasons why this is not a function. And, heck, we only needed 1 reason. Okay, so we've looked with a list of ordered pairs. We've looked with a table. So now with number 3, we're going to have what's called a mapping diagram. Oh, he's on it already. Any other group got a thought on this before I let him steal it? Oh, yes, table 4. We need to let you get your point. It's not a function and say why again? This is for you, dear. Yes. Okay, so, and you can have a point for that. So it's not a function. And our issue is with negative 8. Negative 8 is going to negative 4. And negative 8 is going to 14. Now, I don't know about you, but the mapping diagrams sometimes are hard for me to read. So many arrows going on. So if you want to make a list of the ordered pairs represented in that diagram, you can. 4 goes to 14. Negative 8 goes to negative 4. Negative 8 goes to 14. And if you make this list because you can't read the diagram, heck, then you notice negative 8's repeated. For sure, I know I'm right. So if you're having trouble with the diagram, I suggest making a list. Okay, and even more good news. There's one more example on the next page. Example 4. Yes, Travis, before he steals it away. It is a function. And that is true. And you can have a point for that. And you're just going to leave it up. You just know you're going to know all the things.
No, it's going to say why.
Yeah, you're going to know all the things today. I'm positive of that. Okay, so, no, I'm confident with that. So, are there any questions on function, not a function? Okay, that part's normally pretty good for most people. It's a repeat. Now we get to the fun part in life. Here's the part that's algebra 2 with trig. It's not enough to just be a function anymore. There are 4 different kinds of functions. Your function can be 1-to-1. It can be onto. It can be both. Or, of course, there's always a chance it could be neither. So your function, if it's a function, you have to decide, is it 1-to-1? Is it onto? Is it both? Or is it neither? Okay, 1-to-1's actually pretty cool. I think they're all cool, but you know. 1-to-1 says, the official definition says each element of the domain pairs to exactly one unique element of the range. So, I'm going to write 1 in domain goes to 1 in range. That's where the word 1 to 1 came from. 1 to 1. 1 in domain going to 1 in range. For a point, looking at this example, it is not 1 to 1. Can someone tell me why that example is not 1 to 1? Yes, dear?
It's 3 and 4, both go to 6.
And this one's not 1 to 1. And it's because of 3 and 4 both go to C. That is completely correct. Okay, so 1 to 1 is pretty easy to spot, but I think onto is even easier to spot because onto says each element of the range corresponds to an element of the domain. So in my English world, I have to rewrite things in Compton English. So all in range have a match. If there's a value in the range that doesn't have a match in the domain, it is not onto. So for a point, looking at this example, it is not onto. Can someone in some group tell me why this one's not onto? Abby Grace, that's the fastest hand I've seen today.
Because it doesn't have like a domain that's in range.
What value? Okay. So, and it's not onto, and that one's really easy to spot because of C. Look at poor C. He's not mapped to nobody. Onto, super easy to spot. Is there someone in the range who doesn't have a match? And then I say it's super easy to spot. The easiest to spot is both. Because if they're both, it says each element of the domain is paired to exactly one element in the range. So we're really looking for some ordered pairs. We're looking for pairs. Everybody has a match. We're paired up. One person, it's like couples. One boy to, well, theoretically, one boy to one girl. That's how that's how my parents taught me it was supposed to be. So that's going to be my example with that. Okay, so now we have to go back through our 4 examples, and we have to decide the domain and the range. And we also have to decide if it's a function 1 to 1 onto neither or both. Okay, so for instance, we go to our first one. Domain. Table 6. How many points do y'all have? Earth to table 6. Earth to table 6. How many points do y'all have? Huh? 2? Then one of you wants to volunteer for this. Can you list off the things for the domain or the range? Easy points going once.
Andrew, you ready?
Oh, I've got a different group to offer it to before I go to you.
Andrew's ready.
Different points going twice. Different points sold. Okay, table 4. How many points do y'all have?
We have 2.
You have 2? Then you want to list off domain or range. Give me some values. I just need the list of numbers.
-6.
Uh-huh. 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 And the range?
-1.
Uh-huh. Uh-huh.
-7.
Look how easy that was to get a point, table 6. So at the end of the week, when your mama asks why you don't have points, I'm going to reference this exact easy moment. You got to get together on the next one. Okay, so, and you can have a point for that. So now for the hard part. 1 to 1, onto, neither or both. Yes, ma'am.
Is it onto? Because the 2 9s.
Okay. Does every, and I don't like the way you explained it. Otherwise, yes, you're correct, and you can have a point. I put onto because question mark. Can someone use other words to explain why it's onto? Yes, ma'am.
Because the -5 is paired with the -9 and 6 is paired with -9. And they're the same range. -9 and -9 are the same.
Okay.
Same range.
Again, this is our first one to practice. Do you want to say words before I say words?
There's the range number is repeated, maybe?
You can have your half a point to finish your math. Yeah. Onto because all in range have a match. It is for sure onto. Now we've got to ask ourselves if it's 1 to 1. And Abby Grace doesn't know it, but she's going to get her point for her words she said, because she didn't mean to explain why it was 1-to-1, but she did, or why it wasn't 1-to-1. It is not 1-to-1. And Abby Grace explained it because, and you don't have to explain it in real life, I'm just telling you now in case you need a reason, because of the negative 9s. Because negative 5 and 6 both mapped to negative 9. That's a problem. They can't both go to negative 9. It's a problem. So it's just on 2. It's not 1-to-1. Okay, number 2, I need a list for the domain and range. I'm offering it to you again. Going once. Going twice. Sold. Mason, how many does your table have? How many does table 3 have? Table 4?
We have 3.
Okay, then you want to tell me the domain and range again?
Yes.
Okay. I'll humor you. Okay. So we want to help him fix that?
Oh,
wait.
Negative 1 and 2.
Yeah, you don't have to repeat them. Thank you. And then the range, so you can keep your point then. And then but you gotta tell me the range first.
Negative 2.
Yeah, thank you. Okay, we don't have to decide if this is 1-to-1 onto both neither. We don't have to decide that because it's not a function. Not a function. Okay, and then number 3, I need to know the domain and the range for it. I know. That's where the word domain is. Yes, dear.
2, 4, and it looks like negative 8.
It is. And the range?
Negative 6, negative 4, 12, and then 14.
Okay, and then I need to know, are we 1-to-1 neither or both? Or do I?
It's not a function, so it's neither.
It is. If I'm being a real smart pants, though, I can point out, even if this is not a function, so we don't have to do this. But it wouldn't be on to because that 12 has no match. And it wouldn't be 1-to-1 because 4 and negative 8 are both going to 14. Yes, you can have your point.
Yeah.
Okay.
Do we get a first question?
Yes.
I think we should do it.
I think that I'm going to be happy, even though we didn't get as far as everyone else, but y'all did move groups. However, I'm going to say for homework, while everyone else has to finish the notes, you don't, but you do have to try number 4. I need the domain, the range, 1-to-1 onto neither both. The group that has the correct answer tomorrow will get 2 points to start off. 2 points. 2 points. Okay, go ahead and tag it on up. Luke, pass out those steady guys and see who's missing. So no Alex is there.
You can go over.
Man, this is you. You're gonna have to do this. I spent the whole class on my phone, and I'm not surprised I didn't go with my group today. Get together.
Our group was equal today because of Andrew on here.
Just number 4 in the notes. The next one in the notes. Travis. Just that's all. Andrew, Brayden, 11 and 12. I don't remember the numbers. You guys didn't ask anybody.
It's 11.
Andrew. Jemiah. Eric. Everett. Yes, sure. That grade you did is good. You're on my nerves. You know you can't line up at the door like this. Brady, I know you're mine. I got a pretty one that's got no name. I bet it's yours. Jalen. Matthew. Matthew. Naya. Lyric. Jessica.
Wow, that's great.
Erica. I see a whole bunch of Greeks about to lose a whole. Ooh, you better be glad that's all right. You're so close to losing points today. Okay, I'm ready.
It's a big
Yeah. I knew there were some of the fishiology, and I knew we could figure this out. Thank you. Goodbye, Nan.
Have a great day.
You too. Loving the enthusiasm.
Yeah.
Woohoo!
I get a point for that?
Oh, absolutely. Don't you think?